Okay, Math 3, Unit 2, Section B. Today we're talking about solving and graphing absolute value equations, which we've already done, right? We pretty much understand how to solve absolute value equations. And so I'm hoping that this won't be too difficult. So we all understand that A determines the width and direction of our absolute value. Remember that absolute value is the distance a number is away from 0, right? And so if you have like the number 3 on a number line, so if you were looking at, a number line here, and you have, here's 0, and here is -3 and +3, both of them are 3 units from 0. Does that make sense? And so that's what absolute value is talking about, is the distance a number is from 0. We can solve absolute value equations algebraically. And so the first thing you always want to do is isolate the absolute value. What does isolate mean? Good. So I'm just going to put by itself on the left side of the equation. Once you do that, you change to 2 equations. And there'll be some special cases. For instance, and when they say 2 equations, the reason why you're going to make 2 equations is because inside the absolute value, it could equal a negative number, and then when it comes out, it's positive. And inside, it could be a positive, and when it comes out, it's a positive. So it always comes out as a positive. But when it's inside the absolute value, it can actually be a negative. Is there any -0? No. And there are some times when you have, like, let's say you get the absolute value by itself. Let's say we have something like this. Well, can an absolute value equal a negative number? No. So that answer would actually end up being no solution. Okay? So there's 2 different types of special cases. There's when your absolute value equals a negative, and then there's also when your absolute value equals something like 0. And that's a special case because there's actually only one answer. Okay? All right, and then you would solve each of the equations. So what we're going to do today for a few examples is we are going to solve it on a graph, and then we're going to solve it algebraically. Same problem. Does this sound okay? All right. So the first thing we're going to graph is f of x equals the absolute value of x minus 4. So how would I graph that equation? What do we start with? Very good. So for f of x, okay, my vertex is at 4, 0. So we go right, 1, 2, 3, 4, up 0. And then my a value on this one is what? 1. So that's where we'd go like up 1, left 1, up 1, right 1. And then we can draw our line. And absolute value equations are actually 2 lines going in opposite directions because of the absolute value. What? Okay. So this is our f of x equation, and we could label that as f of x. And then we also have our g of x equation. So this one says g of x equals 3. So where do I go to make the line g of x equals 3? Good, y equals 3, so we're going up to 3 right there, and then we're just drawing a straight line. Okay, and that is my g of x equation. So the question is, and hopefully maybe you draw things better than me, but if you were to keep doing the slope on here and on this one, do you see the points where the 2 graphs intersect? So where do they intersect at? X equals 1 and x equals 7. Do we see that where the points cross? Yes? Okay. So now let's look at it algebraically. So it says solve algebraically f of x equals g of x. So I would write this equation as the absolute value of x minus 4 equals 3. Okay, is the absolute value by itself? Yes. So see how this absolute value over here, there's nothing adding to it, there's nothing subtracting, there's nothing multiplying. The absolute value is by itself and everything else is on the right side. Okay, so then we're going to make two equations. So inside the absolute value, we could end up getting a positive 3, or it could be inside, it could be end up being a negative 3. And actually at this point, we could take the absolute values away. But we'll just leave them there for this minute. Okay, so in order to get the x by itself, now what would I do? Add 4. And so we would get x equals, and 3 plus 4 is 7. Over here, if I add 4 to both sides, we get x equals positive 1. So if you think about this, if you were to plug this in, 7 minus 4 is 3, and the absolute value of 3 is 3. If I were to plug in 1, 1 minus 4 is negative 3, but when it comes out, it is a positive 3. And so we were able to show here that algebraically we get 7 and 1, and graphically we also get 7 and 1. What? Is that good?
Well, I was just like confused on it.
Oh. Yeah, so we're just solving the same problem two ways. Okay. So, number 2. How will we graph that one?
Vertex, the f of x is negative 2, 0.
Okay, good. So our vertex is negative 2, 0. And we all understand we take the opposite of what's in the absolute value, and there's nothing adding it to the end, which makes it 0. So we're going to go left 2, up 0. Make a point. And what is my a value on this one? Good, negative 3 over 1. So we're going to go down 1, 2, 3, right 1, and down 3, left 1. And then we can go ahead and draw our lines. Okay, and then our other equation is what?
Just where x is and y is 2.
Good, so we're going to go up to 2 and draw that line. Okay, and it's a good idea to always label them too. So that was g of x, this one is f of x. And where do those lines or graphs intersect? Never. So this one's no solution. Okay? Well, let's see what that looks like algebraically. So again, f of x equals g of x. So we write this out and we have negative 3 absolute value of x plus 2 equals 2. Is the absolute value by itself right now? No, so what would I do? Divide by negative 3. Because this negative 3 is multiplying to the absolute value, so in order to get rid of multiplication, we undo that by division, so those cancel. We get absolute value of x plus 2 equals negative 2/3. Well, can an absolute value ever equal a negative number? No. So that's why that is no solution.
So what about the top where it said in the absolute value where it's x minus 4 equals negative 3? And that came out.
Right. Okay. So do you see how we got the absolute value by itself and it was a positive 3? Okay. At this point, you can set up two equations. Because inside this absolute value, it could be a negative, but it's going to come out as a positive. And so that's why we set a negative equation and a positive equation. And so remember how I showed you how if we were to plug 1 into this equation, 1 minus 4 makes a negative 3, but then when it comes out, it becomes a positive 3. So you remember the first step is to isolate the absolute value. Once you isolate the absolute value, if the answer is a negative, then it's no solution. Okay? If it's a positive, then you're going to set up your two equations. Okay? And then if it's a 0, you just have one equation. Did you say you're still confused?
No, I remember this.
Are we okay now? All right. Any other questions? And so graphically, we can see too that there is never a time that these two graphs intersect, okay? Which makes sense why there's no solution, where here we could see that it crossed twice, okay? Which is why there's two answers. Okay. All right, so now we have example 3. Okay, so we're going to do this one together, and then I'm going to have you do number 4 on your own. Okay, so let's go ahead and graph first. So what would I do in order to graph this one? What is my vertex? Negative 1, 5, good. And then my A value is 1/2, good. Okay, so we go left 1 and up 5, make our point. And then from there, we're going up 1, right 2, or up 1 and left 2. Okay, and that was f of x. And then where do I go for g of x? Y equals 5, good. And so we draw this line. And that's my g of x. And you notice how many times does this cross? Once. Okay, and what is the value for x at that point? Negative 1. So it looks like there's only one answer for this one. Okay, so if there's only one answer, what do you think is going to end up happening over here? There's only going to be one answer, which means it's probably going to end up equaling 0 when I get the absolute value by itself. Okay, so let's go ahead and work it out. So our equation would be 1/2 absolute value of x plus 1 plus 5 equals 5. In order to solve this, what would I do? First, you would get rid of any adding or subtracting. So we first subtract 5. We have 1/2 absolute value of x plus 1 equals 0. And then how do I get rid of that 1/2 there? What would I do? Multiply by 2. Or you can even write it as 2 over 1, because see how that all cancels everything? And whatever you do to the one side, you also do to the other. And so we get the absolute value of x plus 1 equals, and 0 times 2 is 0. So do we see how we wouldn't set up two equations? Because there's no such thing as a negative 0. All right, and then we subtract 1 to both sides, and we get x equals negative 1, which is the exact answer I got when I graphed it. Okay, any questions? All right. So I would like you to do number 4 on your own. When you get the answers for where the graph crosses, raise your hand and I'll come check them. And I might even give out candy for the first few that have the right answer. Where did you get the answer algebraically of 3 and 3? You just plugged it in.
Yeah.
Okay. So I want to see how you work it out algebraically. Okay, you got it. Okay. I know that's okay, this is what you're doing. So the first step is that you want to isolate the absolute value. Once you have the absolute value by itself, then you make 2 equations. You made 2 equations at the very beginning. So you first need to isolate the absolute value. Okay, so you did the same thing. So the first thing you always need to do is, if you go back and look at the directions, isolate the absolute value, then change it to 2 equations. Okay? So when you isolate the absolute value here, you have this. And then your second equation should just be x minus 1 is negative 2. No, this one is fine. It's this one. And if you notice, you have 3 here, so that one matched. Okay, I'm going to go through number 4 here. Okay, so a lot of you, as I walked around, the step that you guys forgot about is that you first have to isolate the absolute value on the left side, and then you write 2 equations. Okay, so on this problem, when we're doing it algebraically, and we set this up, I have 2 absolute value of x minus 1 equals negative 1. Wait, no, let's try that one more time. 2 absolute value of x minus 1 minus 1 equals 3. So we have to isolate the absolute value. So what will I do first? Add 1 to both sides. 2 absolute value x minus 1 equals 4. Is the absolute value by itself? No, so what do I do now? Divide by 2 to both sides. And so I get the absolute value of x minus 1 equals 2. So now that the absolute value is by itself, I can make my 2 equations. So you would have x minus 1 equals 2 and x minus 1 equals negative 2. So it's only at that point that you end up writing your 2 equations. Does that make it more clear? Okay, and so then here I add 1 to both sides and I get x equals 3. Here I add 1 to both sides and I get x equals negative 1. To graph it over here, my vertex was at 1, negative 1, and my a value was at 2 over 1. So we go 1, negative 1, and then from there I go up to right 1 and up to left 1. Draw my lines, and then my answer, let's see here, g of x equals 3. So we go up to 3. Draw our line, that's g of x, this was f of x. Am I missing something?
No.
Okay, and then our points are at 3 and negative 1. Okay, are there questions? No, we're good? Okay, so part of your homework is going to end up being doing both, and then part of it is just doing absolute value equations algebraically. You don't have to do it graphically as well. Okay, so on number 5, is the absolute value by itself? Yes. So we're just going to set up 2 equations. So we have 2x minus 8 equals 12, and 2x minus 8 equals negative 12. So here we add 8 to both sides. 2x equals 20. Divide by 2 and I get x equals 10. for my other equation, I add 8 to both sides. 2x equals a negative 12 and 8 makes, good. Divide by 2 and we get x equals negative 2. So on a number line, how would you graph that? And you only have to mark these numbers for me. So negative 2 would end up being on the left and 10 would be on the right. And it's just 2 points. No, you don't. I mean, you can mark 0 if you want to, but you don't have to. Okay, questions? All right, so number 6 is the absolute value by itself. No, so what would you do first? So we divide by negative 2 because negative 2 by the absolute value means multiplication. Okay? Now what? Very good. And how do we know it's no solution?
Negative.
Because it equals a negative. Because we can have a negative inside here and it can come out as a positive, but you can't have, it will never come out as a negative, right? Okay, so this one is no solution. All right, number 7, is it by itself? No, the absolute value is not by itself. What would you do first on that problem? Subtract 7. Good. No, because the 3 is not actually adding. The 3 is multiplying to the absolute value. Does that make sense? So this 3 is actually connected there. All right, so this cancels. We have 3 absolute value of x plus 1 equals, and 16 minus 7 is 9. Then your next step would be to do what? Good. Divide by 3 to both sides. And so we have the absolute value of x plus 1 equals 3. And now what do I do? Good. Now you can split it into 2 equations. Okay, so we have x plus 1 equals 3 and x plus 1 equals negative 3. Subtract 1, x equals 2. Subtract 1 and we get x equals negative 4. So on the graph, we would have a point at negative 4 and a point at positive 2. Okay, do we have questions? All right, I want to see if you can do number 8 on your own here. And when you get the right answer, raise your hand. I'm going to give candy again for the first 3 that get it right. Oh my goodness. Okay, we got one already too. Okay. Good. Okay, so the two answers were 18 and negative 12. For time's sake, I'm going to go ahead and go through this. So the first thing, you always want to isolate the absolute value. So we add 1 to both sides. I have 1/5 absolute value of 2x minus 6 equals 6. Okay, is the absolute value by itself? No, so you can get rid of 1/5 by multiplying by the reciprocal, which would be 5 over 1, or just 5. So this all cancels out. Absolute value of 2x minus 6 equals 30. Is the absolute value by itself? Yes, so this is the point right here where we write two equations. We have 2x minus 6 equals 30, and 2x minus 6 equals negative 30. Okay, we add 6 to both sides. 2x equals 36, and we divide by 2 to get x equals 18. Am I going too fast? Okay, add 6 to both sides. Whenever we have a negative and a positive, subtract, take the sign of the bigger number, so I get a negative 24, and then we divide by 2, and x equals negative 12. So on our graph, we have a negative 12, and then we have a positive 18. Okay, what will I do on 9? What's the first step? Good, subtract 5. Absolute value of 2 over 3x equals, and 13 minus 5 is? 8. Good. Is the absolute value by itself?
Yes.
Okay, so we make two equations now. I have 2 over 3x equals 8, and 2 over 3x equals negative 8. Okay, how do I get rid of the 2/3? Multiply by the reciprocal, so in this case it would be 3 over 2, and whatever I do to one side, I also do to the other. You can make 8 over 1. Okay, so these all cancel. Okay, the 2 and the 8, 2 goes into 8 how many times? 4. So we end up with 4 times 3, which is 12. Okay, you could have gone 8 times 3, which is 24, and got 24 divided by 2, which will also give you 12, or you can reduce before. So here I'm going to multiply by 3 over 2 to both sides. Okay, again, I reduce if I want to, and 2 goes into 8 4 times, but now I have a negative 4 times 3, which makes x equal to negative 12. All right. And then the last one, number 10, what would I do? Good, always start with adding and subtracting. We subtract 4. I have negative 1/3, absolute value of 5x equals 3. Next, in order to get rid of negative 1/3, what do? Multiply by a negative 3, or negative 3 over 1. Whatever we do to one side, we do to the other. These all cancel. Absolute value of 5x equals, which means what?
No solution.
And why is it no solution? Exactly. Okay, questions?